Hello to everyone. This is Krishnamani, Assistant Professor, Department of Computer Application in Lebanon College of Engineering and Technology. Today's topic is UML diagram, use case diagram, activity diagram, sequence diagram, and dump class diagram. UML diagram is a unified model language diagram, a visual representation of a system that shows how different components interact. It's similar to blueprint. UML is not a programming language rather than a visual language. We use UML diagram to show the behavior and structure of the system. UML helps software engineer, business, and system architect with the model and design and analysis. Types of UML are behavior diagram, structure diagram, and under the behavior, activity, state machine diagram, interaction diagram, use case diagram, and under the interaction diagram, communication sequence, interaction overview, then timing diagram. Whereas structure diagram, class diagram, component diagram, package diagram, object diagram, composite diagram, deployment diagram, and profile diagram. Students say use case diagram. Define the user interaction with the system. Use case diagram represents the system functionality connecting one for perspective like design, implementation, process, and deployment. For every single functionality represented a fresh diagram is used. Hence, multiple use case diagram represent multiple complete system components. System, that means system boundary or subject, use case, actor, relationship, and association in under generalization, exclude, and include. Next, system boundary. It is also referred to the scenario or functionality. Notation of system boundary is a rectangle with the system name on the top of the rectangle. All the use case and functionality of specific system are located inside the rectangle. The actor accessing the system are placed outside the system boundary. Next, actor. Actor is the entity that interacts with the system. The actor is external to the subject and hence lies outside the system mode. Examples: student, customers, like that. Notation of the actor is sticky man. The actor using case service is called primary actor, and the maintainer or providing services called services to the use case is called supporting or secondary actor. Next, use case. Use case represents the function unit of a large application. Notation horizontally shaped oval and it is located inside the system boundary. The system is not owner of the use case. The interaction and the action between the events or actor and data lead to the end result, which is the use case code. Next is relationship. Relationship, that actor use case can have an association with each other. A line between use case and an actor denote a communication link between them. Association between actor and a use case can be binary. A use case can be linked to multiple actor, and as an actor would be also be associated with multiple use case. Next, include, extend, generalization. In include is mandatory. Base use case is completed by itself. Include use case is required. Notation of that, the dashed arrow with an arrowhead from the include base case to the include common part use case. The relationship notation is labeled with the keyword include. Then one is extend. It is an optional behavior. Base use case is complete by itself. Extend use case is required. Notation is the dashed line with an open overhead labeled with the keyword extend. Generalization base use case is the abstract use case. Specialized use case is required. The notation is a line with an arrow shows generalized relation between the two components. Next, this is the use case diagram examples. This is use case diagram, 18 use case diagram. Next is a sequence diagram. Sequence diagram map out Step-by-step interaction between objects. A sequence is a key component of UML used to visualize the interaction between objects in a sequential order. This sequence diagram illustrates object interaction, message flow, and a sequence of operation, making them valuable for understanding use case, designing system architecture, and documenting complex process. Notation of the sequence diagrams is actor, lifeline, message, synchronous message, asynchronous message, create message, delete message, self message, reply message, found message, lost message, and guards. Next, actor. Actor is similar types of rule where it interacts with the system and its object. It is notated by the sticky man. Next is a lifeline. Lifeline is a named element which represents an individual participant in a sequence. So basically each instrument in a sequence diagram is represented by lifeline. In this element are located at the top of the sequence diagram. Next is message. Message is communication between object is represented using message. The message appear in a sequential order on the lifeline. We represent message using arrows. Lifeline and message from the core of the sequence diagram. It is classified into two types: synchronous and asynchronous. Synchronous means reply before the interaction can move forward. The sender wait until receiver has completed the processing message. Next, asynchronous is does not wait for the reply from the receiver. The interaction moves forward irrespective of the receiver processing previous message or not. Next, create message. Create message to initiate a new object to the sequence diagram. It represents a dotted arrow and a create word labeled on it to specify that create message. Delete is an object. When an object is reallocated, memory is destroyed with the system. We use the delete message symbol. Next is a self message. Self message. It is a scenario may rise where object need to send a message to itself. Next is a reply message. Reply messages are used to show the message being sent from the receiver to the sender. We represent return or reply using open arrow with the dotted lines. Next, found message. Found message is used to represent a scenario where an unknown source sends the message. It is represented using arrow directed towards the lifeline from an endpoint. Lost. Next one is lost message. Lost message is we represent a scenario where the recipient is not known to the system. Next is a God. God is a model condition. We use God in UML. They are used when we need to restrict the flow of message on the pretext of condition being met. God plays an important role in letting software developer. Next, this is the example of sequence diagram. Activity diagram represent process decision flow and dynamic system behavior. Similar to process flow chart, it provides a representation of process sequence and decision point. It helps visualize workflow, process and or activity within the system. It shows the steps involved in how a system works, helping us understand the flow of control. An active diagram start from initial point and end with the final point, showing different decision path along the way. There are often used business and the process modeling to show how a system behaves over time. These are the notation of activity diagrams. Final state, action or activity state, action flow or control flow, decision mode and branching, next guard and fork, then join, major merge event, simulants, time event, and the final state or end state. Final state or end state denote the end of the flow. We fill the circle within a circle notation to represent the final state in the state machine diagram. This type of process can have multiple final state. Next is a class diagram. Class diagram define system structure with class attribute and relationship. Helps everyone involved in a project like developer, designer understand how the system is organized and how its component interact. Help to communicate and document the structure of the software. These are the notation of the class diagram. In the class diagram represents a box. Each contains three compartment of the class name, attribute and method. Class name is always typically written in the top of the compartment of the class box and is centered and bold. Attributes also known as a bracket of it represent the data member of the class. They are listed in the second compartment of the box. Next, method. Method is also known as a function or operation representing the behavior of functionality of the class. They are listed in the third compartment. Visibility notation. Visibility notation indicate access level of attribute and methods. Common visibility notations are there: plus for public and minus for private, hash for protected, and tel for package or D for visibility. Next, parameter directionality. In this diagram, parameter directionality refer to indicate of the flow of information between classes through method parameter. It helps specify whether parameter in an output or input or both. In represent input, out represent output, in out represent in and output. Its relationship between classes. In class diagram, relationship between classes describe how classes are connected to interact with each other. Association, directed association, aggregation, composition, generalization that means inheritance, realization that means interface implementation, next dependency relationship, next usage or dependency relationship. That's all about. Thank you.